T-minus 10, 9, 8, 7, 6, 5, 4, 3, Atlas ignition, 2, 1, and liftoff. Liftoff, the United Launch Alliance Atlas V rocket with the 5th space-based infrared system satellite for the United States Space Force.
Now 15 seconds into flight, PU's gone to closed loop control. Engine operating parameters continue to look good.
You are hearing the voice of Patrick Moore providing launch vehicle ascent data.
Vehicle's now completing the pitch over program, body rates look good. Seeing good chamber pressure on both SRBs. And RD-180 now beginning the throttle bucket, engine response looks good. And now passing through Mach 1, Atlas V is now supersonic, and max Q, maximum dynamic pressure. Body rates continue to look good through the boost phase. Vehicle's now throttling back up slightly, engine response continues to look good. Chamber pressure on both SRBs continue to look good. Now passing 1 minute 10 seconds into flight. Atlas is now 10 miles in altitude, 4.5 miles downrange distance, traveling at 2,000 miles per hour. 1 minute 20 seconds into flight, standing by for SRB burnout shortly. Body rates continue to look good. Chamber pressure on the SRB is now tailing off. And we have burnout on both SRBs. Atlas will hold on to the SRBs for an additional 39 seconds before jettison. RD-180 is throttled back up to full thrust. Engine response looks good. Now passing 1 minute 50 seconds into flight. Body rates continue to look good throughout the boost phase. And the Atlas V now weighs 1/2 of its liftoff weight. And standing by for SRB jettison shortly. And we have good indication of separation of both SRBs. Now just under 2 minutes remaining in the booster phase of flight. Vehicle's gone to closed loop steering, seeing a slight correction in the body rates, now damping out nicely. RD-180 engine operating parameters continue to look good. RD-180 throttling down slightly now as expected. Two minutes 40 seconds into flight. Atlas is now 39 miles in altitude, 68 miles downrange distance, traveling at 5,400 miles per hour. And the Centaur reaction control system is now pressurizing the flight levels. System response looks good. Now coming up on 3 minutes into flight. RD-180 pump speeds and injector pressures continue to look good. Body rates continue to look good. Now about 1 minute remaining until booster engine cutoff. Pump speeds and injector pressures on the RD-180 continue to look good throughout the boost phase. Three minutes 30 seconds into flight. Atlas is now 56 miles in altitude, 160 miles downrange distance, traveling at 9,000 miles per hour. And RD-180 is now throttling to maintain a constant 5G acceleration limit. RD-180 responses look good. And Centaur's begun the boost phase chill down sequence. RD-180 now going to 4.6G throttle limiting, standing by for BECO. And we have BECO booster engine cutoff, standing by for stage set. And we have good indication of stage separation. We have pre-start on the RL-10, standing by for ignition. We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good. And we have good indication of payload fairing jettison. This first burn of today's mission will last approximately 10 minutes 30 seconds. RL10 engine operating parameters look good. Body rates have damped out nicely from the startup transients. And the RCS system has begun the initial thruster firings for system thermal conditioning. Just over 5 minutes now into flight. RL10 chamber pressure looks good. Body rates continue.
This is Atlas Mission Control at T plus 5 minutes, 20 seconds. Patrick Moore just confirmed successful completion of the early phase of today's flight, and all systems continue to operate nominally. The mission is currently in the first Centaur engine burn. Our next event, Centaur main engine cutoff, will occur in approximately 10 minutes. Lockheed Martin builds the SBIRS satellites for the U.S. Space Force. Here's a video highlighting the power of these satellites.
It's 30 seconds into flight.
Last week, I had the opportunity to talk with Lockheed Martin's Melanie Young about the incredible capabilities SBIRS 5 brings to the constellation. Let's take a look at our conversation. Hey, Melanie. Thanks for joining me this afternoon. Can you tell me more about what you do for the SBIRS program?
Yeah, thanks. I'm really excited to be here. I am a systems engineer for Lockheed Martin Space, and I've worked in the U.S. Space Force's Space-Based Infrared System, or SBIRS program, for 14 years.
Wow, that's awesome. For our audiences, can you tell us more about what SBIRS is and what SBIRS does?
Yeah, SBIRS is a critical system for the U.S. Space Force and for our national defense. It has a constellation of SBIRS satellites that continuously protect our nation and armed forces. The SBIRS satellites are equipped with scanning and steering surveillance sensors. They detect missile launches and support ballistic missile defense, expand technical intelligence gathering, and bolster our situational awareness on the battlefield. On the ground side, there's a ground station that receives and processes tons of SBIRS data. The SBIRS operators take that data and use it to make reports for defense and intelligence and civil applications. And SBIRS GEO 5 is the latest satellite to join the SBIRS constellation.
So the SBIRS program is very important to our national defense. You mentioned that this is SBIRS 5. We've launched 4 SBIRS birds in the past. Can you tell us what's different about SBIRS 5 compared to the previous satellites?
Yeah, we're very excited about SBIRS GEO 5. It's the most advanced and resilient SBIRS satellite that Lockheed Martin has built to date. It was built in about 5 years, and it's the first military space satellite built on our LM-2100 combat bus. So that is the version of Lockheed Martin's modernized modular LM-2100 space vehicle. It has greatly enhanced resiliency. That LM-2100 bus is an internally funded multi-year modernization initiative that has greater resiliency and cyber hardening, enhanced spacecraft power and propulsion and electronics. It's got a lot of processing and features as well, where we have common components that streamline manufacturing. And then it's got a flexible design so that you can put on future modernized sensor suites. So this is a huge step toward achieving, this resilient missile warning that is ultimately going to follow on in next-gen OPIR Block 0.
Wow, that sounds really important. That's really a significant upgrade compared to the previous birds that we've launched. I know for me, working in the industry, I find it really rewarding to participate in some of the launches that we do, both national defense and some of the science missions. What's it mean to you to work on the SBIRS program?
Yeah, I'm really proud to be a part of the SBIRS program, supporting our national defense. And SBIRS plays such an incredibly important role in protecting our country and our armed forces. And I'm really proud to be a part of this team.
Awesome. Well, hey, thanks for talking to me today. We recently received some sad news that a mutual teammate, Bill Levinson, had passed away. I know that Bill had a tremendous career with Lockheed Martin. He's also a longtime ULA employee when we formed ULA in 2006. He worked in our chief engineer's office, both in the major development as well as the chief engineer for the Delta program and then the Atlas program. He contributed in numerous ways to all of our programs.
Yeah, we thank Bill for his many years of service to the industry, and he will be missed.
Well, thanks again for joining me today, Melanie. It was really great speaking with you.
Yeah, thank you.
Once operational, the Space Delta IV team at Buckley Air Force Base in Colorado will control the SBIRS GEO 5 satellite. Let's take a look at a short video message.
Hi, I'm Captain Hannah Ritter.
And I'm Second Lieutenant Nicholas McDaniel.
We're here at Buckley Air Force Base, Space Delta IV. With faster, more accurate missile surveillance capabilities, this is a step forward for the future warfighter. As a space-based infrared operator since 2017, this historic event on May 17th will be the launch of SBIRS GEO 5, will greatly contribute to the mission of protecting the United States and our allies.
The launch of this satellite further proves that the space enterprise is here to stay, and we can't wait to gain operational control of this satellite and support our nation and our allies.
Videmus Mundum, we see the world.
This is Atlas Mission Control at T plus 11 minutes, 30 seconds. The Atlas, Centaur second stage, and SBIRS GEO 5 satellite are currently located over the Atlantic Ocean, west of Africa. Our next event, first Centaur main engine cutoff, or MECO 1, is coming up in a few minutes, followed by deployment of EZ3 and EZ4. Once again, here's Patrick Moore.
Temperatures as expected, and telemetry quality continues to look good. Now coming up on 12 minutes into flight. Approximately 3 minutes now remaining in the burn. And Centaur is now 125 miles in altitude, 2,200 miles downrange distance, traveling at 17,000 miles per hour. "12 minutes, 30 seconds into flight. Chamber pressure on the RL-10 has continued to look stable throughout this burn. Now passing 13 minutes into flight. And just over 2 minutes now remaining in the burn. Centaur systems all continue to operate nominally. And continuing to see some periodic thruster activity on the reaction control system as expected. Propellant utilization system is continuing to control appropriately in the closed loop mode. Body rates remain stable. Now coming up on 14 minutes into flight. And about 1 minute now remaining until main engine cutoff. Chamber pressure continues to look good on the RL-10. Body rates remain stable. About 35 seconds now remaining until engine cutoff. And we're seeing good pressures on helium and hydrazine storage bottles. And standing by for engine cutoff shortly. And we have MECO main engine cutoff. Body rates look good. Centaur now engaging 4S settling as expected. And standing by for CubeSat deployment shortly. And we have good indication of separation of the TDO3 CubeSat from the aft bulkhead carrier. Centaur now rolling 180 degrees in preparation for separation of the TDO4 CubeSat. And roll rate is now damping out. And the roll is completed, standing by for separation of TDO4. And we have good indication of separation of the TDO4 CubeSat from the aft bulkhead carrier. Now 16 minutes, 30 seconds into flight. Centaur has resumed 4S settling following successful separation of the aft bulkhead carrier payloads.
I'm joined now by Lieutenant Bryce Leader, EZ3 and EZ4 Program Manager. Lieutenant, thanks for joining me. We just saw the successful deployment of EZ3 and EZ4. Congratulations.
Hey, thanks so much. It's such an exciting event to watch. I mean, fantastic launch to watch, fantastic separation. Really, just thanks to our partners here, ULA and Parsons, for all the hard work they put in so far. So it's looking good. So thanks again.
Excellent. As EZ3 and EZ4 Program Manager, what's your role?
Yeah, it's a great question. So I want to point out I'm a Space Force program manager now, which is kind of a big deal for me. Just transitioned recently, but I'm based out of the Mission Manifest office, which is a subset of SMC out of Los Angeles Air Force Base. And I know that's kind of a mouthful, but pretty much what we do is we try and maximize the capability on the launch vehicle through multi-manifesting. And we've done this on 3 missions so far.
Who built TDO 3 and 4?
Yeah, so TDO 3 and 4 was built by DNet Integration and Design. It's a small company out of Denver, Colorado. One thing I do want to point out, though, is one of the partnerships we had on this mission was with United States Air Force Academy. It was the first time working with them, and it was a great experience. Really hope we can do it again in the future here.
I bet that was an incredible experience for the cadets.
Oh, it was so great. We actually got to get them out here for the EZ3 and EZ4 matchmate. So I actually got to
Excellent.
watch them bolt on the flight system. So that's really exciting. And as an Air Force Academy alumni myself, I couldn't be more excited to see the next generation of officers, Air Force and Space Force coming out.
Cool.
Yeah, go Falcons.
So we've heard the terms EZ3 and EZ4 and TDO 3 and 4. Can you explain the difference?
Yeah, it's a great question. A lot of people often get this confused. So EZ3 and 4, each EZ flight system is exactly that, a complete flight system that's strapped onto the aft end of the Centaur, whereas TDO 3 and 4 are the specific satellites that are integrated into the EZ3 and 4 flight system.
What's different from EZ3 and EZ4 compared to previous missions?
Yeah, so I love that you asked this question because it lets us brag a little bit about our capabilities in the Mission Manifest office. So the first 2 missions we had are very similar to the configuration we have for EZ3 and 4. The main difference, though, is that we actually have twice the amount of satellites on this mission compared to our previous 2 missions, which were HF5 and HF6. Another fun fact is this is actually our second time doing a U.S. Space Force mission. So it's awesome that we're building our capability as we expand into the Space Force as well.
So has the National Security Space Launch Program ever deployed these EZ-SATs prior to the primary anchor payload?
Yes, so actually on that HF5 and HF6 mission that I mentioned before, we deployed both of those satellites before the primary payload as well. And why that's important is because certain satellites have specific requirements that our warfighters need. So ultimately, we're getting critical capabilities to our warfighter when and where they need it.
So what's next for the Mission Manifest Office?
Well, we're pretty busy here, Dylan. We got quite a few missions coming up. But one I want to highlight is a partnership with NASA on the Landsat 9 observatory mission. We're actually populating an entire ESPA ring that's going to have up to 13 satellites on it.
Wow.
Yeah, so that's
allows it to hold things that most normal planes wouldn't usually be able to hold. Most planes need palletized cargo, whereas we can fit larger cargo such as helicopters, tanks, and satellites. So yeah, this is a special mission because we only have two C5s capable of doing that mission, and we don't do it very often, so it's a privilege to be able to contribute to the space mission. So in order to prepare for these space missions, we have to, as an aircrew, be very cautious and prepare much more thoroughly in regards to turbulence, in regards to weather, routing, making sure that no hazards are going to be in the way that might potentially damage the satellite or the container that it's in. It could damage the satellite, so we need to be very cautious on especially important missions. We even have another C5 going in front of the C5 carrying the satellite just to scout out the air ahead of us if there's any turbulence or weather that we need to avoid. And we will be trying our best to make this landing as smooth as possible in order to prevent it from getting damaged. So yeah, the loadmasters are essential in this. They're the ones who basically run everything to do with the cargo. They are the most, I would call them the most essential part of the C5, or of the satellite and space mission, just because it takes usually up to a day, 2 days in order to safely and correctly put these containers on. So the amount of expertise that it takes our loadmasters and our engineers in order to get these things on safely and correctly is astounding. Working with the civilian community and the space community in order to move these satellites is just a great experience and a different experience than what we're used to working with military only.
This is Atlas Mission Control at T plus 25 minutes and 20 seconds. We are a few minutes away from the restart of the Centaur main engine. Let's go back to Patrick Moore.
Centaur systems all continuing to operate nominally. And vehicle is continuing the PTC roll, and we are continuing to see the periodic thruster activity on settling as expected. Now passing 26 minutes into flight. And 5 minutes now remaining in the coast. Now passing 27 minutes into flight. Centaur systems all continuing to operate nominally throughout this coast. Vehicle is continuing the PTC roll. Vehicle body rates remain stable. Storage bottle and tank pressures continue to look good. Main vehicle battery temperatures and voltages also look good. ICS loop temperatures are continuing to track very closely with the storage bottle temperature as expected. Now passing 28 minutes into flight. And Centaur should be beginning to conclude the PTC roll in preparation for the next burn. And we are seeing the roll come down to conclude the PTC. And Centaur now adjusting its attitude. Now passing 29 minutes into flight. And in a little over 2 minutes, the Centaur engine will ignite to begin the second burn of today's mission. 23 seconds prior to ignition, the RL-10 will begin the fuel and oxidizer pre-start sequence. This burn should last approximately 3 minutes and 20 seconds. And body rates have all milled out now in preparation for the burn. And Centaur now engaging 100% 4S settling. And just under 1 minute now remaining until engine restart. Tank pressures are increasing in preparation for the burn. And we have fuel pre-start on the RL-10. .15 minutes until main engine start. And we have LOX pre-start. Standing by for ignition. We have ignition and full thrust on the RL-10. Chamber pressure looks good. Body rates look good.
As Patrick Moore just reported, the Centaur main engine has been restarted for a second engine burn. This burn will last approximately 3 more minutes. The Atlas V continues to travel in a southeasterly direction. Following our next event, MECO 2, or cutoff of the Centaur RL-10 engine, the Atlas V will cross over the African continent where the trajectory will switch to an easterly heading. Separation of the SBIRS GEO 5 satellite will occur over the Indian Ocean east of Madagascar. Let's go back to Patrick Moore.
Chamber pressure throughout the burn. Vehicle autopilot is controlling well, seeing good stable body rates in the closed loop control. PU system operation looks good. And 2 minutes now remaining in the burn. Body rates remain stable, and RL-10 engine operating parameters continue to look good throughout this burn. And about 100 seconds now remaining in the burn. And seeing a good constant acceleration of the vehicle during this burn. PU system operation continues to look nominal, and we are continuing to see periodic thruster activity on the RCS system as expected. Loop temperature staying close to bottle temps. 1 minute now remaining in the burn. Body rates continue to look stable as vehicle is controlling in closed loop. Now 30 seconds remaining in the burn. Centaur systems all continue to look good throughout this burn. PU's gone to open loop in preparation for MECO and standing by for main engine cutoff shortly. And we have MECO main engine cutoff. RCS is now at 100% settling as expected. System response looks good. And Centaur is now turning to the separation attitude.
This is Atlas Mission Control at T plus 34 minutes and 55 seconds. We just heard the call for successful second main engine cutoff. Our final mark event in today's show, spacecraft separation, will occur in approximately 12 minutes. Joining me now is Lieutenant Adam Farah. Lieutenant, thanks for joining me.
Thanks, Dylan. Pleasure being here. Seeing launch was awesome, and I'm excited.
Awesome.
Yeah.
As program manager for the 5th and 6th SBIRS satellites, what are your responsibilities? What's your average day look like?
Yeah, great question. So I'm an acquisitions officer in the Air Force, and I'm part of the Systems Engineering, Integration, and Test Integrated Product Team, or IPT, for GEO SBIRS 5 and 6. So with this, my responsibilities, I manage risk associated with the program. I review earned value management data. I plan the early on-orbit test campaign, and I contribute to the launch readiness review process. And with these responsibilities, my day can get pretty busy. An average day, I reach out to individual IPTs with regards to risk. I review contractor data. I attend virtual meetings, and then I report my findings or assessments to upper leadership. But I really enjoy my work, and I really enjoy working with the contractor and government team that I work with. And it's been awesome, and I think we've done a great job adapting in this all telework COVID environment.
Oh, it's been a very challenging year, no
Yeah.
doubt.
For everyone.
So we've heard a lot about the SBIRS satellite today. Can you
Yep.
give us some additional background on the SBIRS capabilities and the development of the
Yeah,
program?
absolutely. So the Defense Support Program, or DSP, was the original missile warning capability for the United States. The first satellite was launched in 1970, and the last satellite was launched in 2007. And in the span, there were a total of 23 DSP satellites put into constellation. Like I said earlier, this was the original missile warning capability fielded by the United States, and this is where SBIRS fits in. So SBIRS was designed to replace the DSP constellation, and now in the missile warning constellation, we have DSP satellites, we have HEO, or highly elliptical orbit satellites, and we have GEO, or geosynchronous Earth orbit satellites. Now, in regards to evolution, and with GEOs 1 through 4, and then 5 and 6. So 1 and 4 were built identical to each other, and 5 and 6 are functional equivalents of each other. However, they both have a design change in the bus, as well as minor design changes to account for material and parts obsolescence. And I think this just shows how our capabilities are evolving to help our military defend from the national security threats that we have.
So how does the SBIRS program benefit the warfighters on the ground?
Yeah, great question. I think that's really important that that gets answered, because ultimately our program is here to support the troops and to defend the nation. And in today's global environment, the number of threats is greater than ever, and these threats are evolving at a very fast pace. So it's important that the military and our capabilities like missile detection, missile deterrence on a global scale are, it's important that these are where they are and where we need them to be. And that's where, again, SBIRS fits in. So we provide that global, persistent infrared surveillance capability that the troops on the front line, as well as our nation, need to defend against this ever-changing 21st century threat environment. And again, or not again, but I just want to bring in a real-world situation
Sure.
where this capability helped, or actually shows how we help troops on the front line. So in January of 2020, Iran attacked al-Assad Air Base in Iraq, where U.S. troops are stationed,
Mhm.
and space operators were able to, using SBIRS capabilities, were able to detect the threat, warn U.S. troops who are on the direct path of the missile. Due to the early detection, no U.S. troops were harmed or killed, and I think, again, this just shows how our capabilities are actually helping the troops on the front line.
Yeah, an absolutely critical
Yeah,
capability,
exactly.
no doubt.
Very important.
So obviously, liftoff is super exciting
Yeah.
to see. We're just a couple minutes away now from spacecraft separation. What are you feeling right now?
Yeah, so that was awesome. That was the first lift or launch that I've ever been a part of. And I just want to say congratulations to everyone who has gotten this far and worked with the team. And I know the mission isn't over, but still getting here is such an accomplishment. Watching everything come together and now being moments away from spacecraft separation is amazing. And however, this is only the beginning of the SBIRS mission. So once spacecraft separation happens, then we need to make sure we get in our desired orbit, as well as make sure the satellite is functioning properly. So we start with a series of liquid apogee engine burns to get into our circularized orbit. And then we turn on the satellite, turn on the payload, and make sure that, again, the systems are functioning properly. And once all of this happens and we're in our desired orbit and in the constellation, then that's when the SBIRS mission actually begins. Now, another reason why I'm really excited and why everyone's super excited is because this is the first time in the Space and Missile Systems Center history that Space Force acquisitions officers have sat on console for day of launch. So for SMC, for the Space Force, for um, the nation, and for our program, it's just a remarkable accomplishment to get to this point, and I couldn't be happier. And I know everyone on our team feels that same way.
Well, thanks for sharing your perspective. It
Yeah.
sounds like you have a really cool job, and appreciate appreciate you talking with us here as we
Yeah.
get closer to SBIRS separation. Hopefully, you can hang out with me here in the booth for just a couple more minutes.
Yeah, don't worry, I'm not going anywhere.
Awesome. This is Atlas Mission Control at T plus 41 minutes. We're approaching spacecraft separation here in just a few minutes. Let's go back to Patrick Moore for the last call of the afternoon.
Now just over 90 seconds remaining until spacecraft sep. Centaur systems all continue to look good. And vehicle is now beginning to arrest its roll in preparation for the separation. Now 1 minute remaining until spacecraft sep. And roll rate is nulled out. And Centaur now adjusting roll rate for spacecraft sep. "20 seconds to separation. Centaur now spinning up in preparation for separation, standing by for spacecraft sep. And we have good indication of separation of the SBIRS GEO 5 spacecraft. And following spacecraft separation, we have approximately a 37.5 minutes coast prior to MES 3.
Congratulations to the dedicated teams across the nation on a successful launch and delivery of SBIRS GEO Flight 5 to orbit. And Lieutenant, congratulations to you and your team as well on a successful mission. Thanks for joining me today.
Yeah, thank you. Such an awesome day, and go SBIRS GEO Flight 5.
My thanks also to Patrick Moore for his participation in this afternoon's broadcast. You can continue to follow the mission live on ulalaunch.com or follow us on social media. We'll leave you now with one final look at the liftoff of SBIRS GEO Flight 5 at 1:37 p.m. Eastern today. On behalf of the entire launch team, I'm Dylan Rice. Thank you for joining us and have a great afternoon. T-minus 10, 9, 8, 7, 6, 5, 4, 3, Atlas ignition, 2, 1, and liftoff. Liftoff, the United Launch Alliance Atlas V rocket with the 5th space-based infrared system satellite for the United States Space Force.
Now 15 seconds into flight, PU's gone to closed loop control. Engine operating parameters continue to look good.
You are hearing the voice of Patrick Moore providing launch vehicle ascent data.